Imagine if you could experience the sheer intensity of an entire planet in just 5 seconds, where blistering heat meets bone-chilling cold, raging storms swirl over alien landscapes, and the very fabric of space and time seems to bend. In this wild, rapid-fire journey through our solar system, we'll give you a visceral taste of what it's like to stand on the edge of Mercury's inferno, get lost in the toxic beauty of Venus, leap through the dusty plains of Mars, and plunge into the turbulent depths of Jupiter and beyond, all in the blink of an eye. Earth as a baseline. Let's start by letting ourselves be enveloped by Earth's familiarity. You can feel the soft caress of a warm breeze, the soft rustle of leaves, and the calming hum of life that fills our whole ecosystem in the first few heartbeats of our trip. Picture yourself standing on a green hill where the air smells like rain and dirt. It's a place that makes you feel right at home. Our planet's right mix of air, water, and moderate temperatures makes it possible for life to thrive. This makes for a wide range of settings, from quiet woods and lakes to busy cities and roaring waterfalls. Earth is different from other worlds because it is known and close. Other worlds are harsh and strange. As we observe Earth's dynamic conditions, think of the seamless dance between calm and chaos. One moment, you may find yourself enveloped in a gentle, sunny afternoon, where the world seems to pause in peaceful harmony. In the next, a sudden burst of wind or a rolling thunderstorm can transform the scene into a dramatic display of nature's raw power. It's this constant interplay, a baseline of stability interwoven with moments of unpredictable beauty, that makes Earth the perfect reference point. Our environment, with its ever-shifting weather patterns, reminds us that even within a single day, the spectrum of life's experiences can be both tender and tumultuous. Envision stopping on Earth, a world where every breath holds the whispers of evolution that spans billions of years. As you stand under a sky that has seen countries rise and fall, feel the soft touch of a warm breeze that once carried the first seeds of life across the seas. Ancient tectonic forces formed these beautiful mountains and peaceful valleys. Here, in this familiar refuge, the rhythmic dance of day and night supports life at its most basic level. This isn't just a place to relax, it's also a live record of our shared history. It's a strong nursery for wildlife, and every rock and stream there tells a story of cosmic art. Earth shows off both its beauty and the delicate balance that has allowed life to thrive right now. It sets a bar that other worlds' wild extremes will be judged by. During our 5-second snapshot on Earth, you might picture the crisp blue of the sky overhead, contrasted with the deep greens and browns of ancient forests. The surface beneath your feet is alive with the slow, relentless energy of plate tectonics shaping mountains, carving valleys, and creating the diverse landscapes that have inspired poets and explorers for millennia. This is a world where even the simplest elements, the soft rustle of a leaf, the gentle ripple on a pond, or the echo of distant thunder, carry the weight of millions of years of evolution and natural artistry. Earth not only gives us a visual and physical feast, but also a deep sense of belonging in these brief times. We know that this world is our home because of the steady rhythm of day and night, the predictable cycle of the seasons, and the healthy environment that supports billions of people. It's a starting point, a steady, calm thing to compare against as we get ready to go on our crazy trip to other, much crazier places. There is a big difference between Earth and the rest of our solar system. Life on Earth seems stable and balanced, but things are anything but safe there. Earth is like a soft song that calms our souls, a symphony of soft sounds and textures that make us want to rest, explore, and think. Every breeze tells tales of lost lands and modern wonders. Every raindrop brings the hope of a fresh start, and every ray of sunlight shows the complex pattern that nature has made. There is a careful balance of warmth and coolness, light and shadow, motion and silence in these 5 seconds. It's a small example of what makes life on Earth so valuable. Mercury. Mercury is the planet that is closest to our Sun. It is a hot, empty world that makes us question how we can survive. In just 5 seconds on Mercury, you'll feel the scalding heat, the icy cold, and the constant barrage of cosmic forces. This is all in a place with no atmosphere, so there is no room for pity. Just picture walking out onto a surface where the sun is beating down like a furnace and the temperature is always changing. When the sun's rays hit Mercury's day side, they heat it up constantly, quickly raising the surface temperature to over 400 degrees Celsius, 750 degrees Fahrenheit. The ground shimmers like a dream in this scorching heat, and even the rocks seem to give off energy. As you stand there, you can almost feel the heat coming off of every grain of regolith. Regolith is a fine, powdery material that covers the Earth and was made when meteors hit it billions of years ago. Each tiny particle is a record of a violent past and a reflection of the sun's pure energy. But just as quickly as the heat takes over, the lack of an atmosphere means that the temperature drops sharply at night or when you move to the side that is in the shade. What was once a fire turns into a cold wasteland very quickly. The temperature can drop to almost minus 180 degrees Celsius, minus 290 degrees Fahrenheit. Going from a very hot furnace to the middle of a cold night is a lot like this quick change. When you look deeper into Mercury's mysterious surface, you find a place that is full of science mysteries. The Messenger mission showed that Mercury's surface is mostly made up of finely powdered regolith, which is made up of iron-rich minerals and chemicals that have been exposed to space weather. The regolith in this area was formed by meteoroids impacting the Earth billions of years ago. It shows that the Sun and other space objects have been very active in the past. Data from Messenger show surface reflectance values and temperature differences that paint a picture of a world where the sun's rays turn every rock into a small oven during the day and a freezing pit at night. These features tell us that Mercury, in its natural unprotected state, is one of the harshest places in our solar system to study how planets change over time. The lack of atmosphere on Mercury is both a curse and a window into a stark, unfiltered reality. Without an atmospheric blanket to retain heat, the planet's surface is directly exposed to the harsh realities of space. This means not only do you face extreme temperature fluctuations, but you're also subjected to the constant bombardment of micrometeorites and cosmic radiation. Imagine feeling every tiny impact as the ancient dust and rock, hurling through space at breakneck speeds, collide with the surface. These impacts, though seemingly insignificant on their own, have over eons shaped Mercury into a pockmarked, rugged terrain of craters and fissures. Each crater tells a story of cosmic violence, a testament to the countless collisions that have sculpted this mysterious world. During those 5 seconds on Mercury, the sun's constant closeness is too much for you to handle. Here, the sun isn't just a faraway star, it's a huge, constant fireball that rules the sky. Its light seems to burn through space, leaving only heat and light behind, even when there is no atmosphere to block it. Since they are so close, every ray of sunlight shines brighter, giving the surface a strange, almost surreal shine. The sharp shadows that the rocky rocks and crater rims cast add to the drama by making contrasts that are both beautiful and harsh. It looks like the surface of Mercury is always changing, with new pictures of harsh conditions being taken every second. Think about how this fast exposure to the sun might change the geology of Mercury. The constant unbending heat causes the rock formations to change quickly. Some materials grow and shrink in cycles that are hard to see from Earth, where we are far away and safe. This heat stress makes the surface break up into pieces, where cracks and splits show up surprisingly often. You can almost feel the energy that makes these things happen. The sun's constant push and pull, which shapes the planet's face in ways that are both violent and fascinating. Mercury has a unique, rough beauty, even though it is in a hard environment. The rough, empty surface, shaped by time and cosmic crashes, is a picture of extremes. The landscape is lit up by bright, almost blinding sunshine one moment, and then thrown into deep, freezing darkness the next, revealing the clean lines of its old scars. Mercury has been around for billions of years and has always been about both making things and destroying them. This cycle has a beautiful sadness to it. Each crater and ridge is a silent record of the planet's long history. They give us a look into a world where impact marks and thermal scars show how much time has passed. Just imagine going through this as a person. In 5 seconds, you're thrown into a world where every breath is a battle with nature's extremes. The extreme heat on one side, the sudden bone-chilling cold on the other, and the raw, uncompromising presence of the sun above make for a sensory overload that is hard to find anywhere else. This experience is very powerful and almost too much to handle. It makes you face the raw power of our solar system. There is no safety net here. You are open and vulnerable, but also deeply amazed by the beauty of this cosmic furnace. In these fleeting seconds, Mercury becomes a microcosm of celestial extremes, a planet where the fundamentals of physics are played out in a relentless display of energy, matter, and time. The absence of an atmosphere strips away the softening filters we're accustomed to on Earth, leaving you with the raw, unadulterated essence of what a planet can be. It's a world of contrasts and contradictions. Scorching days that seem to melt the very ground beneath your feet, followed by nights so cold they could freeze the blood in your veins. This dichotomy, so extreme and so rapid, encapsulates the unforgiving nature of Mercury, a realm where survival is a constant negotiation with the forces of nature. Venus. Venus wraps you in a veil of burning, smothering beauty. It's a world where the air is a deadly mix of acids that break down things and crushing pressure that crushes you. During these 5 seconds on Venus, you're thrown into a place that is unlike anything you've ever seen before. It's like walking into a fiery hell where it's always dark. The air here is so thick and heavy that every breath would feel like breathing in a deadly storm of acid compounds. Using Earth as a reference, picture how areas of active volcanoes and extremely hot deserts would be like Venus's greenhouse effect going too far, but on an astronomically large scale. The sulfuric acid drops in Venus's atmosphere make a veil that reflects light and almost blinds us, turning sunshine into a bright, scattered glow. In the past, missions like the Soviet Venera series and NASA's Magellan probe have helped to solve mysteries. They have shown that the yellowish colors of the clouds are caused by a complex web of chemical processes. Because of the intense heat and pressure, these processes create an environment that is both hostile and scientifically rich, which is why experts from all over the world are still interested in it. The runaway greenhouse effect becomes painfully clear as you look at the scene. Venus's surface is a scorching plain where temperatures are so high that lead would melt. This is a steady reminder of how close the sun is. The scenery is more uncertain and almost violent when there is volcanic activity. Molten lava runs back and forth across the scarred land, showing that the planet's core is always moving and changing the shape of its surface with bursts of fire. Heat and rust are always dancing with each other, with the molten and the toxic living together in a delicate but risky balance. The sun's harsh closeness. The scenery is more uncertain and almost violent when there is volcanic activity. Molten lava runs back and forth across the scarred land, showing that the planet's core is always moving and changing the shape of its surface with bursts of fire. Heat and rust are always dancing with each other, with the molten and the toxic living together in a delicate but risky balance. Above this fiery landscape, thick dark clouds hide Venus's secrets, leaving it in a creepy twilight that never ends. What's below these moving yellow and orange clouds is hidden, adding to the mystery of a world that was already very mysterious. Their constant movement gives us a glimpse into the wild dynamics of a planet that is always changing. On this planet, the interaction between the chemistry of the atmosphere and extreme weather conditions creates both beautiful and dangerous phenomena. There is a barrier made of clouds that both protects and threatens because they trap heat and dangerous gases, making every second on Venus intense and overwhelming. Mars? Mars greets you with the red colors of a world known for being quiet, empty, and hauntingly beautiful. In these 5 seconds on Mars, you'll see a scenery that is both strange and strangely familiar. It's a world that has scars from ancient rivers and tall volcanoes, but is still mysterious. In addition to its eerily beautiful empty landscape, Mars has strong signs that it was once a world with lots of water. Mineral deposits, old riverbeds, and rare outcrops of sedimentary rock all show that water used to move easily, creating deep valleys and creating possible homes. Recent robot efforts have found signs of temporary water activity on Mars. This gives people hope that the planet may have been home to life in the past and could even support human settlement in the future. Mars is not only a natural mystery because of its low gravity and surface that still shows signs of being wet, but it is also a hopeful place for humans to take their next big step in exploring other planets. Imagining yourself on the surface of Mars and feeling the light pull of its low gravity, it would be like you're in a dream as you move around. For a moment, the weaker gravity turns every step you take into a graceful, almost balletic leap. It's like dancing slowly against the setting of a barren, wind-swept desert. The thin atmosphere on Mars makes the sky's soft glow look like it's from another world, leaving long, soft shadows that fit in with the scenery. You might feel a soft, almost imperceptible buoyancy here, as if the planet's lighter touch is asking you to float along its old red passageways. Yet Mars is not merely a gentle giant of low gravity and dusty expanses. It is a realm of relentless shifting forces. Imagine, too, the sudden swirling dust storms that can engulf entire regions, transforming a calm afternoon into a scene of otherworldly chaos. These storms, both fleeting and formidable, pick up fine red particles and send them swirling in a dance of wind and grit, blurring the line between serene beauty and raw, untamed power. In just 5 seconds, you could witness the subtle interplay of light and shadow as a dust storm begins to whisper its arrival. A reminder that even in the apparent stillness of Mars, the forces of nature are ever at work. Mars is even more mysterious because it is so far away from everything else. Far from Earth's busy energy, the red planet gives off a deep sense of stillness. Standing on its surface, you feel enveloped in a quiet, almost hypnotic silence. The huge open fields and steep, rough terrain make you feel like you're in a place where time has stopped and the sounds of a long-ago age can still be heard. This isolation isn't just physical, it's also mental. Facing a world that has grown in almost complete silence for billions of years makes you feel awe and reflection. In these brief seconds, Mars challenges you to see beyond the surface, a world of subtle beauty hidden beneath its dusty exterior. A planet where low gravity and shifting sands create an environment that is both inviting and mysterious. As you take in the sweeping vistas and the gentle pull of the Martian gravity, you are reminded that this red, desolate landscape holds secrets yet to be discovered. Jupiter. Jupiter surrounds you with a symphony of chaos and wonder, a huge storm that is unlike anything you've ever felt. The atmosphere of Jupiter is roiling with wild energy, and storms are as big as gigantic whirlwinds. You are smack in the middle of a spinning giant for 5 seconds. Imagine a world where huge clouds that are always changing shape form the famous Great Red Spot, a storm that is bigger than Earth and has been going on for hundreds of years. Jupiter is a scary planet, and it's not just because it looks like a storm. Its magnetic field is the largest in our solar system, and it makes huge radiation belts that are both a shield and a threat. Charged particles are trapped by these magnetic forces, which creates beautiful auroras that can be seen from Earth. The Galileo and Juno missions have given us new, in-depth information about these events, revealing the complex processes of Jupiter's magnetic environment and core. They made important discoveries that give us a look into the strong forces that shape the growth of gas giants like Jupiter, turning it into not only a huge stormy monster, but also a complicated, multi-layered system of cosmic energy. As you look at this bright and raging show, the layers of constant motion show you what Jupiter's atmosphere is really like. The upper parts are a beautiful painting of orange, white, and red swirls, that give you a taste of the complicated chemical makeup and changing processes going on below. The weather here isn't still. It's a mosaic that's always changing, with bands of clouds flying by at speeds that can easily go over 400 km per hour, 250 miles per hour. These bands make a beautiful patchwork, a complicated mix of light and dark that hints at the rough forces that are moving inside. You can almost feel Jupiter's energy pulsing through this short meeting. It's as if every gust of wind and spinning vortex is alive and breathing Jupiter's own heartbeat. The overwhelming pressure of Jupiter's lower atmosphere becomes palpable, a force that would crush an ordinary human body in an instant. As you imagine venturing further down, the air thickens and the intensity of the storms grows even more ferocious. The pressure here builds to levels that are almost inconceivable, compressing the gases into a near-liquid state where even hydrogen, the lightest element, is forced into unfamiliar, dense forms. The winds intensify, whipping around with a ferocity that can be likened to a cosmic roller coaster, a wild, unpredictable ride through layers of energy and heat. Every second on Jupiter feels like a high adrenaline plunge into the unknown, where the elemental forces of nature are laid bare in their most extreme forms. In spite of all the chaos, there is an interesting puzzle about how Jupiter is put together. Even after decades of studying and looking into it, no one has figured out what's hidden beneath those moving clouds. Scientists are still not sure what the planet's core is made of, and what its huge, gaseous shell is really made of. Some theories say that the center is made of a thick layer of metallic hydrogen, while others say that it might be made of strange, unknown materials. Each idea is just as crazy as the last. You get a glimpse into a world where the usual rules of physics are pushed to their limits in these 5 seconds. The very things that make up this giant are still a mystery. It's like Jupiter is smiling at you and daring you to figure out how it fits into the big picture of the universe. The strange makeup of the world can be seen in the way its surface is always changing. The bright, swirling designs you see are not random. They are caused by gases interacting in complicated ways at very high temperatures and pressures. Clouds of ammonia, water vapor, and other chemicals mix in ways that make the atmosphere lively and almost alive. The way these elements interact creates layers with lots of small details, from the thin wisps of cloud that float on top to the rough, swirling depths where the pressure and heat combine to make a huge wave of energy. Every time you look up, you see something new. A bright flash of color here, a storm building quickly there. Each is a moment in an endless dance of chaos and order that is always changing. In these brief moments on Jupiter, it's hard to ignore how big the planet's natural forces are. The sky is both amazing and humble because of the huge pull of gravity, the huge forces of pressure and heat, and the constant movement of the clouds. It's like seeing the raw, unchecked power of creation itself. This power has been at work creating planets and stars with an almost holy intensity since the beginning of our solar system. When you look at Jupiter, you have to question how much you can understand. It reminds you that even the strongest forces are just brief moments in an endless cosmic dance in the big picture of the universe. Imagine being in the midst of this ceaseless storm, feeling the full force of Jupiter's turbulent energy in just 5 seconds. Every roar of wind, every swirl of color, and every pulse of pressure is a reminder that you are on a world where nature operates on a scale far beyond our everyday experience. The experience is both exhilarating and intimidating, a wild, breathtaking encounter with the raw edge of cosmic power. You're not merely observing, you're participating in a dance of elemental forces that have been sculpting the cosmos for billions of years. This is Jupiter at its most elemental, a planet that is not only massive in size, but also in the intensity of its natural phenomena, a living, breathing embodiment of chaos and wonder. You realize that Jupiter is more than just a big ball of gas during these brief moments. It's a living system where energy, pressure, and wonder come together to create an endless show of nature's power. The swirling storms, high pressures, and elusive secrets of its makeup all come together to create an experience that is both mentally and physically exciting. Saturn. You're in a world on Saturn right now where beauty and balance work together perfectly for 5 seconds. As soon as you step onto this beautiful world, you'll notice its stunning rings, which are made up of a halo of whirling, shimmering ice and rock particles that form a fascinating ring around the planet. These rings are made up of many pieces from ancient space crashes. They sparkle with a soft light, with each piece reflecting the sun's light like a tiny work of cosmic art. The way they move, which is almost beautiful, makes me think of a world where space is tamed and turned into an amazing, rhythmic ballet. Under the peaceful sight of Saturn's rings, the atmosphere is a lively picture of moving clouds and gentle winds. The weather here is a study in balance. It's not as scary as Jupiter's constant storms, but it's still very interesting. The sky is made up of bands of soft pastel colors that mix with soft layers of gold and cream. These layers of clouds move slowly, as if in a beautiful dance. They are a constant reminder that nature can make a music of calm, even in the void of space. Even though the atmosphere is mostly made up of hydrogen and helium, it is full of complex chemical reactions that make light and shadow patterns that are fleeting and always changing. Picture yourself standing on the edge of this calm chaos, where each swirl of cloud tells a tale of old winds and time passing. During these precious seconds, you are also pulled to the huge difference between how calm Saturn is compared to how wild and violent Jupiter is. Jupiter's storms sound like cosmic typhoons, but Saturn's storms have a more polished sense of order. In contrast, its atmosphere is calm and steady. The planet's slow spin makes it so that even the roughest weather seems to move in a graceful, almost predictable pace. But this calm isn't what it seems. Beneath the soft, colorful layers, there is a strong current of energy that is changing the planet's behavior in small but important ways. The balance between slow and fast motion is not only beautiful to look at, but it also serves as a powerful reminder of the complex forces that control the movement and development of planets. The rings of Saturn, which are probably the most amazing thing about the planet, are not just bands of ice and rock that don't move. They are constantly changing as the planet's gravity and its many moons interact with them. As you watch, you can picture the delicate tug-of-war between the rings' gravity pulls that keeps them in perfect orbit. This dance of astronomical physics has been going on for millions of years. Small particles constantly hit, mix, and break apart, making new things and destroying old ones. With their complicated structure and stunning beauty, these rings act as both a cover and a window. They keep the planet safe from some interplanetary junk and show us how our solar system formed. Take a closer look at Saturn's rings, and you find a mesmerizing interplay of gravity and motion. The rings consist of billions of ice particles, each engaged in a delicate dance dictated by Saturn's gravitational pull and the resonant influences of nearby moons. These particles collide, clump and fragment in a continuous cycle, creating transient patterns that shimmer with an ethereal glow. Early astronomers marveled at these rings, and modern missions like Cassini have revealed the subtle, intricate physics behind their formation and evolution. This dynamic ballet of icy fragments not only accentuates Saturn's breathtaking beauty, but also offers critical insights into the processes that govern planetary ring systems across the universe. Imagine taking in the spectacle of Saturn as your eyes trace the graceful curves of its rings against the backdrop of a vast, deep sky. The rings glow with an inner light, a subtle, iridescent shimmer that changes with every angle of the sun. This interplay of light and shadow creates a moving mosaic, a living, breathing testament to the forces of gravity and time. It is a vision so serene that it almost lulls you into a sense of cosmic calm. A stark reminder that even in the vast, violent theater of space, there is room for beauty, order, and elegance. As you continue your 5-second journey, Saturn's atmosphere wraps around you like a soft, gentle breeze, a contrast to the searing intensity of Mercury and the oppressive heat of Venus. The temperature here is moderate, a gentle reminder that not all planetary extremes are about raw, unbridled fury. Instead, Saturn offers a measured, almost inviting environment, where the subtle play of light on drifting clouds creates an ever-changing panorama that captivates your senses. It is a world where even the faintest whisper of wind carries the promise of secrets waiting to be discovered, where the rhythm of the rings and the cadence of the clouds create a symphony that is both timeless and enchanting. You can get a quick look at a world on Saturn that is just on the edge of chaos and order during these brief times. It is a world that shows that power can be gentle, and that nature's forces can show up in both wild storms and peaceful, mesmerizing displays of heavenly beauty. The beautiful rings around Saturn, the way its atmosphere gently swirls, and the planet's general air of measured grace all work together to make an experience that is both mentally interesting and breathtaking to look at. You shouldn't think that Saturn isn't active just because it's quiet. Underneath its calm surface lies a complex web of forces, including magnetic fields, gravitational interactions, and minor air currents, that keep this magnificent world moving, albeit slowly. These underlying forces give Saturn's rings their shape and keep the cloud's slow, rhythmic pulse going. This keeps Saturn a lively, living part of our solar system's grand fabric. Uranus. Uranus has a mysterious charm that makes it stand out as an ice giant. Its strange sideways spin and calm, dull blue-green colors go against what most people think about planets. Today, for 5 seconds, you're on Uranus, where the extreme cold and unique tilt of the axis create a mood of quiet wonder. As soon as you step foot on this faraway planet, you'll feel an eerie sense of calm. This place is very cold. The temperatures drop so low that even the hardest winter on Earth seems almost pleasant. Uranus's most noticeable trait is its high axial tilt, which causes seasons to last longer than ever before. Imagine that one pole is in direct sunshine for over 42 years, while the other end is thrown into a never-ending freezing night. As a result of these extreme conditions, the atmosphere's behavior and temperature change slowly but dramatically over decades. It's like a dance in space. Uranus's sky has soft, changing colors that aren't just caused by the planet's chemicals. They're also the result of its long yearly cycles, showing us a world where time seems to slow down when it comes to extremes in the sky. Imagine looking out at the horizon, where the sky meets a huge area of frozen clouds, each one hanging precariously in the air. Uranus has a show that is calmer and more meditative than Jupiter's violent swirling storms or Venus's thick, heavy clouds. Along with its strange sideways spin, which makes it look like the planet is rolling along its path, it also has dramatic and unexpected changes in the seasons. In these brief seconds, you see a world where the idea of a day is changed by an axial tilt of more than 90 degrees, which means that each pole has about 42 years of straight sunlight or darkness. This slow, orderly cycle makes it seem like time goes by more slowly, lulling you into the peaceful beauty of an ice giant that hasn't been affected by the chaos of its solar neighbors. As you take in the view, the muted blue-green hues of Uranus's atmosphere captivate your senses. These colors are not the vivid, fiery reds or brilliant whites seen on other planets. Instead, they evoke a sense of tranquility and introspection. The light filtering through its upper layers casts a soft glow that seems to whisper secrets of cosmic antiquity. Every subtle shade, from the pale, icy blue of the high atmosphere to the deeper, richer teal near the horizon, speaks to the unique chemistry of this distant world. It's as if Uranus is softly illuminated from within, its cool light providing a stark contrast to the harsher, more volatile conditions found elsewhere in the solar system. There is an interesting interaction between internal and external forces going on beneath this calm appearance. Uranus's atmosphere doesn't seem as active as the atmospheres of gas giants like Jupiter, but there is a quiet movement going on. Its upper layers have a low level of turbulence, which suggests that strong energy currents and small changes in chemical makeup are always at work below the surface. The planet's slow, almost unnoticeable winds carry the sounds of storms that happened a long time ago, and the gentle rippling of its cloud layers shows how things have been changing for billions of years. It's a delicate dance of frozen elements and slow motion, a natural melody that is both simple and deeply complicated. In these 5 seconds on Uranus, you're also invited to ponder the mystery of its unusual tilt. Unlike any other planet in our solar system, Uranus spins on its side, a characteristic that has perplexed scientists for decades. This peculiar orientation gives rise to extreme seasonal changes that occur over the course of decades, altering the very face of the planet in slow, dramatic cycles. The notion that one pole can bask in uninterrupted sunlight for over 4 decades, only to be plunged into darkness for the next, is a concept as mesmerizing as it is alien. In this brief snapshot, you begin to grasp the enormity of these slow transformations, a planetary ballet performed on a cosmic stage, where every moment is both a beginning and an end. While other worlds have more violent events, Uranus is a calm and peaceful place to visit. There isn't any heavy turbulence or big weather here, so the sense of space and time is very different from what it is like on Jupiter, where things are always changing, or on Venus, where it's always hot and stuffy. Instead, Uranus is a place to think about yourself. It's like a break in the beat of the universe, where you can just look at the subtle beauty of a frozen giant and guess what it's hiding beneath layers of soft, changing light. People are being asked to take it easy and enjoy the soft glow of an atmosphere that has stayed cool through billions of years of cosmic change. Uranus wants you to see a different kind of heavenly beauty at these short-lived times. It's not the big show of raging storms or baking heat. Instead, it's the quiet, constant beauty of a world that knows how to be subtle. Its cold, peaceful presence shows how different the environments are in our solar system. It's a lesson that even in the most inhospitable and faraway places, there is a story of beauty, balance, and endless wonder waiting to be told. Neptune. Neptune takes you to a mysterious, deep blue world where nature's raw power is shown through rapid winds and colors that change quickly and catch your attention. You are thrown into a dynamic mix of fierce weather and surreal beauty for these 5 seconds on Neptune. The air is crackling with energy. As you stand on this faraway cold border, the first thing you notice is the vastness of the deep blue sky, punctuated by whirling, stormy patterns that make you think of forces that are much stronger than anything we normally experience. Here, the winds aren't just gusts, they're wild tempests that can hit speeds of over 2,000 km per hour and whip across the surface of the planet. Presume how shocking it would be to feel these supersonic winds, which can throw you into a spinning vortex of turbulent air. Now think about the raw energy that makes them possible. Every second on Neptune is like being in a cosmic storm, where the fast winds are shaping the atmosphere into crazy, changing shapes all the time. The scene is both hypnotic and confusing because of the way the violent storms and calm, deep blue background interact with each other. The difference is stark. A planet known for its explosive movement is shrouded in a veil of calm, almost hypnotic color that hints at the secrets that lie beneath its stormy surface. Beyond the furious winds, Neptune's isolation on the outer edge of our solar system imbues it with a unique mystique. The planet sits as a silent sentinel at the frontier of our celestial neighborhood, a place where the vast, inky darkness of space meets the planet's vivid, vibrant atmosphere. This juxtaposition of light and darkness, chaos and serenity, creates an environment where every moment is charged with potential energy, where the boundaries between the familiar and the utterly alien blur into one continuous, breathtaking display. In these few fleeting seconds, Neptune's deep blues and swirling clouds invite you to lose yourself in a landscape where nature's might is both unpredictable and profoundly beautiful. The unpredictable nature of Neptune is shown even more clearly by the groundbreaking pictures taken by Voyager 2 of its violent storms, including the short-lived Great Dark Spot. The pictures show a planet with winds of more than 2,000 km per hour that shape its bright blue atmosphere into designs that are always changing and being thrown off. Neptune's air is full of methane, which gives it its bright color and powers the complicated chemical processes that make its weather change all the time. This mix of raw energy and chemical complexity paints a picture of a world that is both scientifically and aesthetically beautiful. It makes us think about the many forces that shape the farthest reaches of our solar system. Here, violent storms churn alongside regions of calm, forming a mosaic of shifting patterns that are as transient as they are captivating. The turbulent interplay of gases, influenced by Neptune's rapid rotation and the cold expanse of space, forms a spectacle that is as intricate as it is overwhelming. It's as if Neptune is a living, breathing work of art, its every gust of wind and every ripple of color telling a story of ancient cosmic forces at work. In these 5 seconds, the planet's chaotic beauty becomes an unforgettable dance of elements, a relentless yet mesmerizing performance on the grandest of scales. When you experience Neptune, you feel it in more than just your eyes. This place is very cold and has strong winds, which make every sound and smell louder. You can hear the wind roaring, the shimmer of frost-like particles in the air, and the deep, echoing hum of a planet that is always moving. You are not just looking at Neptune, you are living its raw energy and feeling the pulse of a world where everything, even the air, seems to have its own beating. This meeting is a stark reminder of the amazing forces that run our world. These forces are both beautiful and dangerous. In these 5 seconds, Neptune captures the wild, free spirit of the outer solar system, a place where crazy weather and hypnotic color come together to make a constant, thrilling show. You have to face the raw edge of cosmic power on this world in order to understand that the edge of space is not a quiet, empty void, but a lively, living tapestry of changing forces and endless wonder. Io, moon of Jupiter. Io is one of Jupiter's most active and extreme moons. As soon as you enter its rough space, it grabs your attention. In these 5 seconds on Io, you're thrown into a volcanic hellscape where the ground is always shifting, molten lava runs like rivers, and there are powerful blasts all the time. Io's surface is a jumbled mess of bright sulfur compounds and burned rock. It was formed by hundreds of active volcanoes that shoot lava high into the thin, unstable atmosphere, and this is where the constant pull of Jupiter's gravity and the tides from its nearby moons bend Io's core, making it very hot, which feeds its volcanic rage. As explosions happen, picture the ground shaking under your feet in a stunning and scary show of raw power. The fiery reds, oranges, and pale yellows of the lava are so bright and almost surreal that they stand out against the dark, rough landscape that is made up of impact craters and broken fields. The environment changes quickly and dramatically, making every second feel like a thrilling roller coaster ride. 1 second, you're bathed in the light of a nearby eruption, and the next, you're immersed in the eerie darkness cast by plumes of ash and gas. Io's harsh conditions aren't just beautiful to look at, they also create an environment that is always dangerous. Because there isn't a protected blanket, even the smallest volcanic event could kill anyone who dares to step into this hot crucible. Delving deeper into Io's fiery heart, consider its critical role in fueling Jupiter's vast magnetosphere. The constant volcanic eruptions on Io release tons of sulfur and other compounds into space, which become ionized and contribute to the formation of Jupiter's powerful radiation belts. This interaction between Io's surface activity and Jupiter's magnetic field creates a feedback loop that continuously reshapes the environment around the giant planet. The interplay of volcanic fire and magnetic forces makes Io not only a spectacle of raw power, but also a key player in the intricate dynamics of the Jovian system. Io is known as one of the least friendly places in our solar system, but it is also a world of stark, unforgettable beauty. Its unstable nature tells a story of geological activity that is unlike anything on Earth. It's a warning of the strong forces that are still changing the scenery around us in space. In these 5 seconds, Io shows what extreme planetary settings are really like. A place where gravity, heat, and constant volcanic activity work together to make a living, changing the picture of destruction and energy. Europa, moon of Jupiter. Europa has an almost surreal feel to it when you first see it. Its icy surface hides one of the most intriguing secrets in our solar system. In these 5 seconds on Europa, you step onto a frozen environment that, even though it looks empty, hints at the chance of an ocean hiding beneath its cracked surface that can support life. When you stand on Europa's surface, the first thing you feel is how cold it is. So cold that it seems to go right through you. Years and years of wear and tear have smoothed out the ice, which stretches out in front of you like a huge, continuous mirror reflecting the light of the sun far away. This isn't a dead, empty plain, though. It's a moving, changing painting. There are cracks and lines all over the surface, which suggests that there is tectonic action far below. These cracks are like veins on a huge body. They pulse with the energy of an ocean deep inside. Each line and crack on Europa is a quiet reminder of the forces that have shaped the frozen world over billions of years. Europa is shaped by Jupiter's gravity and the tides from its neighboring moons. New discoveries and future projects, such as the Europa Clipper, have made us even more interested in this icy world. Scientists are now closer than ever to figuring out how thick Europa's ice shell is and what kind of things might be in its ocean. These projects aim to find out if the ocean below could contain the basic building blocks for life, providing not only a frozen scene, but also a living laboratory with astrobiological potential. Every time we find something new about Europa, it changes from a cold, lifeless moon to a possible place where life on other planets began. In just 5 seconds, you can almost feel the steady beat of a heartbeat under the ice. This heartbeat could contain the building blocks of life. Scientists think that beneath Europa's icy crust is a huge ocean that stays liquid thanks to the friction caused by the tides, and maybe even nuclear decay deep inside it. Because of this chance, Europa could become a place where simple living things could grow and develop in the dark, away from the harsh radiation of space, instead of being a cold, lifeless moon. In these brief moments, you are asked to picture the quiet hum of life stirring in a hidden ocean. If this mystery is solved, it could change our ideas about where life can exist in the universe. The visual landscape of Europa is equally compelling. As you take in the view, the ice around you shimmers with a pristine clarity, occasionally broken by streaks of darker material that hint at the underlying salt and mineral deposits from the hidden ocean. These darker patches suggest that the surface isn't static. It's a living record of material exchange between the frozen crust and the ocean below. Every so often, you might catch a glimpse of a plume, an icy geyser erupting from a fissure, shooting water vapor and tiny ice particles high into space. These transient events, although lasting only a moment, offer a window into the inner workings of Europa, providing clues about the composition of its ocean and the geological processes at work. They are the moon's own brief, spectacular fireworks, a reminder that even in its cold silence, Europa is alive with subtle activity. The climate of Europa, or rather the lack of it, adds to the feeling of being alone and mysterious. The moon's surface is directly open to space because its exosphere is only made up of a thin layer of oxygen. The surface is hit by radiation from Jupiter's strong field because it doesn't have an atmosphere to protect it. This makes the idea of life under the ice even more interesting. Even though the surface is very hard, the ocean below is still a tempting place to be. A thick layer of ice may protect it from the dangerous radiation above. During these 5 seconds, you have to think about Europa's paradox. It looks empty and dangerous from the outside, but it might hide a warm, active, and even life-supporting world below. As you spend this short time with Europa, you become very aware of how beautiful and quiet its frozen world is. The way light interacts with the ice creates a view that is always changing. There are reflections that shine like gems in the weak sunlight, shadows that show the complex textures of a surface that is changing, and minor color changes that give hints about the ice's complicated chemical makeup. With every look, the moon shows a new feature, a new clue to its mysteries. It is both amazing and humbling to be there. It reminds me of how fragile the balance is between brutal, merciless conditions and the hope that life can continue, even in the farthest reaches of our solar system. The quiet, almost surreal beauty of Europa is broken up by the constant reminders of how active it is. The surface's cracks and ridges aren't just frozen scars from the past, they're living, changing things that could be slowly getting wider as the ocean below pushes up, or they could be slowly getting smaller as the ice cools and freezes. You can almost feel the deliberate slow beat of geological time in these 5 seconds. Geological time is so slow compared to human time that it defies our busy lives, but it is so strong that it changes whole worlds. Europa is a unique and interesting stop on our trip because it has both quiet and movement, silence and possibility. Think about how alone Europa must feel, since it is a moon far from the sun's warmth, where the light is dim and the environment is a study in contrasts. But it is exactly this world's isolation that has kept its surface clean and untouched, giving us a look at processes that are mostly hidden from view on the more active worlds in our solar system. During these brief moments, Europa asks you to admire both the stark beauty of its ice surface and the deep mystery of what lies below. Every crack in the ice and every soft shade of blue and white, there is a sign of the unknown, a puzzle that needs to be answered. In these fleeting moments on Europa, the sense of wonder is palpable, a reminder that even the coldest, most remote places in our cosmic neighborhood can harbor the seeds of life and the echoes of ancient dynamic processes. The ice, with its delicate fractures and shimmering surface, stands as a barrier and a bridge between the known and the unknown, between a desolate exterior and a hidden, potentially vibrant interior. Europa beckons you to look closer, to imagine the possibility of an ocean teeming with life, silently thriving beneath layers of ice that have witnessed the passage of time for billions of years. Take a moment to think about how beautiful and mysterious this icy moon is. This world makes you think about what you think you know, a cold exterior that could hide a warm, secret realm of possibility. Europa is a sign of the many mysteries in our solar system because of the way its light and shade play off of each other and its delicate textures. It also has a secret ocean that could support life. It makes you want to think, dream, and go beyond what we think is possible in the search for life beyond Earth. Titan, moon of Saturn. Titan is Saturn's biggest moon. It has an atmosphere that sounds like it came straight from a science fiction tale and alien scenery that can't be explained. You are now in a world on Titan that is unlike any other. The air is thick with mystery, and the surface is shaped by rivers of liquid methane and lakes of ethane. As you take your first breath, you're surrounded by a thick, hazy glow that is colored with warm orange and gold colors. It makes the atmosphere seem like a dream, where reality and thought are hard to tell apart. Imagine walking on a surface where every step is joined by the soft, muffled rustling of a breeze from another world. Titan's atmosphere is a unique mix of mostly nitrogen and some methane. This makes the sky look like it's always twilight and hazy. The light here is dim and spread out, so it never fully lights up the surface. Instead, it casts a soft, even glow over everything, making everything look strange and half-hidden. It's like looking at the scenery through a thick, natural filter that turns it into a scene that seems timeless and almost magical. Titan's surface shows its interesting dualities under this hazy sky. On one side, you can see huge mounds made of biological matter that have been shaped over thousands of years by slow, steady winds. The bright, reflective lakes that dot the countryside are very different from these huge fields of dark, moving sands. These lakes are not made of water, but of liquid methane and ethane. Think of a peaceful, foreign seascape, where the water's surfaces reflect the soft light and the edges are softly blurred, as if they were made by an artist from another world. Some of these lakes are as big as Earth's Great Lakes. They are a constant sign of how Titan's surface is still being changed by active, changing processes. The Cassini mission has shown that Titan's thick atmosphere is a real chemistry factory. Sunlight and cosmic rays cause nitrogen, methane, and many other organic molecules to react in complicated ways. Because of these interactions, there is a continuous orange haze that covers the surface and makes an area full of prebiotic molecules, which are the very things that could start life in the right circumstances. Cassini's accurate measurements of Titan's weather patterns and liquid methane lakes have not only helped us learn more about this mysterious moon, but they have also made us think about what a habitable environment should be like. This makes Titan an interesting mix of strange chemistry and changing natural processes. Titan's weather patterns add another layer of intrigue to this enigmatic moon. Though it may seem quiet at first glance, the atmosphere is in constant motion. Slow, languid winds that have carved the dunes and filled the lakes with a steady, almost hypnotic rhythm. Occasionally, methane rains descend from the overcast skies in soft, persistent drizzles, pooling on the surface and carving shallow channels that hint at the possibility of ancient river systems. These sporadic rains, combined with the gradual shifting of sands, create a landscape that is both transient and enduring. A place where the passage of time is marked by subtle changes that you can almost feel as a gentle, persistent pulse. While you enjoy the view, you become very aware of the strange sounds that describe Titan. Every sound, even a whisper of wind and the sound of leaves rustling, is amplified by the moon's silence, making a beautiful but strange music. The low, steady hum of the wind, the faraway, almost unnoticeable murmur of liquid methane moving through channels that can't be seen, and the creak of shifting dunes all add to an eerie and fascinating soundscape. It's like Titan is talking to you through a language of soft sounds, a language that talks about old processes and how time moves slowly and deliberately. Amidst this serene and captivating environment lies an underlying sense of danger and isolation. Titan's thick, murky atmosphere, while providing a shield against the vacuum of space, also hides countless mysteries beneath its shrouded veil. Scientists have long speculated about the presence of complex organic molecules on Titan, building blocks that could, under the right conditions, spark the emergence of life. In these 5 seconds, you are invited to ponder the profound implications of such a possibility. A moon where the ingredients for life exist in abundance, silently waiting in the dark, cold depths. The very notion that Titan might harbor the seeds of life, however primitive, adds an electric charge to the experience, a blend of wonder, hope, and an insatiable curiosity about what might lie beneath the surface. With its strange mix of liquid methane lakes, endless beaches, and a sky that is always cloudy and mysterious, Titan's scenery is a vivid reminder of how different the worlds in our solar system are. In this place, things that are familiar turn strange, and things that are strange turn tantalizingly familiar. The way light, texture, and color interact on Titan's surface is a sight that makes you question what you think you know and makes you think about all the ways planets could have evolved. Every look shows a new detail, like a shimmering reflection on a methane lake, the soft edges of a sand dune, or the ghostly shapes of hills in the distance that are hidden by a thick orange smoke. During these 5 seconds on Titan, you are not just looking at a faraway moon. You are experiencing a world that is on the edge of what we think of as livable. There is a sense of continuity across the world because of the difference between the strange surroundings and the sound of natural processes, like rain and wind. Titan is a world full of contradictions. It takes Earth's elements and reimagines them in a way that is both beautiful and scary. Triton, moon of Neptune. Triton, Neptune's biggest moon, is an extreme place where the cold, strange edge of our solar system shows itself in a way that makes you question your very idea of life. During these 5 seconds on Triton, you're immersed in a world defined by its retrograde orbit, in which the moon moves in the opposite direction of Neptune's spin. This is a rare and almost daring anomaly that points to a troubled past. As soon as you step on its ice surface, the sharp cold covers you like a shroud, a stark memory of a place so far away and alone that time seems to stand still. A landscape shaped by strong cryovolcanism, with icy geysers erupting every so often and sending plumes of nitrogen and other flammable chemicals into the air. These geysers, which show that the moon's rocks are still moving, give a frozen world some movement. Though they only last a short time, the bursts of material are like cosmic exhalations, strong memories of the forces still at work inside Triton's icy crust. As you watch these events, the moon's surface is lit up by a strange, almost alien dance of shadows and light, caused by the extreme cold and the intermittent heat from the geysers. Triton's interesting feature is its backwards orbit, which suggests it may not have formed with Neptune, but was instead taken from the faraway Kuiper belt. Triton's surface has some interesting features, like huge cryovolcanic plains and active geysers that point to heat sources inside the planet that are caused by its interactions with Neptune's tides. These changing processes suggest that Triton might still be geologically active, even though it is very cold on the outside. Its cryovolcanic flows may give us a look into a liquid or slushy pool below the surface. This story of capture and change helps us learn more about Triton. It shows it as a relic of cosmic travel that has settled into a fixed but surprisingly dynamic place in Neptune's family of planets. Triton's landscape is an intricate combination of frozen fields, rough hills, and huge dark chasms that show how the universe has changed over billions of years. Every crack and crevice in the ice tells a story of a world that has been shaped over and over again by forces from the outside and forces inside. Because Triton's surface is reflective and shines in the faraway sun, it lets us see the small, often secret features of a moon that is on the very edge of what we know. The environment isn't just a static background. It's alive with the sounds of past impacts, tectonic changes, and the slow, steady work of cryovolcanism that is changing its shape. For these brief 5 seconds, you can feel Triton's quiet isolation. This moon is so far away that its silence says a lot. Since there is no dense air around, every sound and tiny movement seems to be exaggerated, like a soft, steady whisper moving across an endless stretch of ice. This place is very lonely, and it feels like Triton is keeping secrets from a long time ago. These secrets are written in the patterns on its frozen surface and in the shapes of its geysers. Being alone is both a curse and a gift. It's a stark reminder of how harsh and unforgiving the moon is, but it's also a tempting call to find out what secrets lie beneath its icy surface. Also, think about Triton's unusual orbit. It goes around the Sun backwards, which makes it different from most of the other moons in our solar system. This backward motion makes it more likely that Triton was caught by Neptune's gravity instead of forming with the planet. This adds another layer of mystery to the story of how it came to be. Triton may have been a wandering object in the past, but Neptune may have caught it. This idea gives this icy world a sense of cosmic travel and old wanderings. The moon's path, the dramatic frozen scenery, and the short bursts of cryovolcanic activity all add up to a picture of a strange and extreme moon. In these precious seconds on Triton, the interplay of cold and dynamic activity creates an atmosphere of profound mystery. The subtle glow of the ice under distant sunlight, the sudden explosive release of volatile gases, and the quiet persistence of a world that has endured the relentless forces of space combine to form an experience that is both visually stunning and intellectually provocative. Every detail, from the crystalline structure of the frozen plains to the ephemeral beauty of a nitrogen geyser, invites you to consider the complexity of a moon that defies simple categorization. 5 seconds on the Sun. Consider that you have the chance to stand on the surface of the Sun for only 5 seconds. This is a fictional situation that doesn't make sense based on the Sun's extreme heat and turbulent plasma environment. Still, think for a moment about what it would be like to live, even if only for a short time, in the chaos where solar storms and nuclear fusion happen. Right away, you're hit with an overwhelming amount of bright light and burning heat that no amount of protection gear could really protect you from. Still, in this brief image, you can feel a huge amount of energy that controls the solar system and shapes the futures of the worlds we have visited. Instead of a solid ground, you would be immersed in an ocean of plasma. where hydrogen atoms fuse into helium in a process that releases enormous bursts of light and heat. Temperatures near the photosphere, the Sun's visible layer, can approach 5,500 degrees Celsius, about 9,940 degrees Fahrenheit, while deeper zones soar to millions of degrees. In these few seconds, the brightness alone would saturate your vision, turning the scene into a glaring white haze. Every molecule of matter around you vibrates with energy, fracturing and ionizing in a perpetual storm of charged particles. Magnetic field lines twist and snap, creating arcs and loops that glow with the radiance of solar flares. If Mercury's extremes tested your endurance, the Sun obliterates it altogether. This is the raw furnace from which our cosmic neighborhood inherits warmth and light. Of course, the Sun's surface, which is called the photosphere, is just the start of its many layers. There is a lot more heat in the chromosphere and corona above it than below it. You could see the graceful but violent spikes called spicules shooting up thousands of kilometers, or prominences circling outward in arcs shaped by magnetic fields in this 5-second station, though you would have to look through an imagined screen that stops instantaneous vaporization. Even more amazing are coronal mass ejections, which are huge bursts of plasma that can damage satellites and power lines if they hit Earth. Strong electromagnetic and gravitational forces work together to shape these storms into fascinating patterns. But behind the beauty lies a relentless storm, a cosmic engine strong enough to keep life going across almost 100 astronomical units, while also being able to send out deadly radiation blasts. During your 5-second encounter with the Sun, time stops. Everything is on fire, from the granules moving randomly across the photosphere's surface to the flickers of solar flares, signaling changes in the magnetic fabric. Instead of an atmosphere, there are layers of plasma that are thick enough to light up the universe, but not visible to humans. It's so powerful that even the strong dwarf planets we've seen, like Mercury or Pluto, look weak in comparison. It emphasizes the delicate point that Earth's home is only possible because the Sun is stable enough at its current age to give off the right amount of light and warmth that keeps us alive. What 5 seconds would be like on different moons? Let's learn more about the different moons in our solar system. Moons are small planets that circle around the big planets and offer their own unique, short experiences. Even though these moons are often dwarfed by their huge planets, in just 5 seconds, they show a wide range of harsh environments and secrets. From lava flows from volcanoes to frozen surfaces and hazy, strange atmospheres, these satellites stretch our imaginations and show us how diverse our neighborhood in space really is. Each one gives us a different glimpse into the wonders of the universe, showing us worlds that are just as dramatic and important as planets, even though they are much smaller. Ganymede, moon of Jupiter. Ganymede is the biggest moon in our solar system. It is a huge world that makes us question everything we think we know about moons. As soon as you step on its surface, even if it's only for 5 seconds, you're struck by how different the older, damaged areas are from the younger, more active ones. Large areas of highly cratered rock show that the moon has been hit by asteroids for a very long time, and wide grooves and ridges show that tectonic forces have changed the shape of some parts of the moon over time. The view is both humble and amazing. Each crater and ridge records a different part of Earth's geological history over billions of years, and each impact is a brief moment caught in the cold, faraway light of the outer solar system. Walking across Ganymede, you'd feel as if you're traversing a living museum of cosmic history. The moon's surface is a mosaic of textures, from the rough, pockmarked highlands to the smoother, more recent plains, where icy materials have been redistributed by internal movements. Here, the interplay between the old and the new creates a landscape that's as complex as it is beautiful. But Ganymede isn't just defined by its exterior. Beneath its rugged surface lies an enigma, a magnetic field, unique among moons, that hints at a molten, possibly metallic core. This intrinsic magnetism interacts with Jupiter's immense magnetic environment, creating a dynamic, ever-changing field of forces that add a layer of complexity to an already fascinating world. In these few seconds, you sense not just the vast cold surface, but also the deep internal rhythms of a celestial body that has quietly been evolving for eons. Ganymede is a beautiful spot, and its environment is also very delicate. Imagine the cool, clear light reflected off of ice forms in the sun far away. There would be no sound in this huge, faraway world, and time would seem to slow down. From where you stand, the contrast between the moon's rough, worn-down features and the smooth, mirrored ice makes for a surreal scene that takes your breath away and moves your spirit. Ganymede makes you think about how big our universe is. Callisto, moon of Jupiter. Callisto has a different story to tell. It is a peaceful, old treasure that seems to have frozen time. As soon as you step onto Callisto for 5 seconds, you're surrounded by a deep silence. The surface looks like a record of the past of the universe that has never changed. Ganymede's scenery is full of chaos and change, but Callisto's is peaceful and almost frightening. Its surface is full of impact craters, each one a quiet reminder of a violent past. But over the years, the chaos of crashes has given way to a long-lasting calm that is almost meditative. The rough landscape, shaped by blasting over billions of years, looks like a tapestry from space. Each crater rim and basin tells a story about the early, chaotic days of the solar system. During these special times on Callisto, the strange regularity of its old surface strikes you. Time has smoothed out the rough edges of creation in a way that can't be denied. Huge plains lie unaffected by tectonic forces, showing a world that hasn't changed much since the beginning of the solar system. On the other hand, Callisto hides secrets that go beyond just natural inertia behind this seemingly dull exterior. Some experts think that this moon's highly cratered surface hides an ocean below. If this is true, the moon would no longer be a barren rock, but a possible source of water that could support life. The idea of an ocean like this being buried under ice and time adds a mysterious quality to the scene, making you want to picture what is going on below the surface. Callisto is beautiful because it is strong and quiet. It is a place where the scars of a violent past have settled into a deep, almost mythical silence. Because there hasn't been much geological action in a long time, each impact crater is still a perfect memory of a different time. As you look out over the huge cratered fields, the soft play of light and shade on the ancient surface creates a calm that seems to come from another world. The only thing that breaks up the silence is the occasional frost. This soft glow, which comes from reflecting the weak sunlight of faraway Jupiter, gives Callisto a dreamlike quality that is both soothing and thought-provoking. For a moment, Callisto stands as a symbol of the eternal and unchanging power of time. It is a calm and quiet defender of the ancient secrets of our solar system. Enceladus, moon of Saturn. Enceladus is very small, but it has a dramatic, almost movie-like energy that makes its icy surface look less dramatic. You're not just a guest to a cold, empty moon during these 5 seconds on Enceladus. You're a witness to one of the most active natural events in our solar system. Cryovolcanoes are short, powerful eruptions that happen on Enceladus's smooth, mirrored surface. The ice sheet looks almost too perfect to be real. Imagine huge geysers bursting from cracks in the ice, sending amazing plumes of water vapor and tiny bits of ice high into the cold air, and leaving behind ethereal, ghostly tracks that light up the dark polar skies. These bursts of cryogenic volcanism are a constant reminder that Enceladus has a secret active ocean below its calm surface. This ocean is a subterranean store of liquid water that is warmed by the pull of Saturn's gravity. The landscape of Enceladus is a study in contrasts, where the smooth, glass-like quality of the ice meets the raw, unfiltered power of its internal heat. Every inch of the surface seems meticulously crafted by the forces of nature. Vast, untouched plains of crystalline ice, interrupted by jagged ridges and occasional fractures that reveal deeper layers of the moon's structure. As you traverse this frozen terrain in your brief encounter, you can almost hear the soft, continuous hum of internal processes at work. Subtle vibrations and shifts that hint at the active geologic heartbeat of a world far more complex than it appears at first glance. The interplay between the cold surface and the warm, churning ocean beneath creates a dynamic balance that is as scientifically fascinating as it is visually stunning. The intriguing thought of life in Enceladus's deepest parts is what makes it so interesting. The geysers are not only a spectacular show, but they also give us a clear view into the Moon's core by shooting out particles that might contain the building blocks of life. In these brief moments, you are asked to imagine a world where life might continue in secret, even though the surface is not friendly, a silent, persistent environment thriving beneath layers of ice. Enceladus used to be a cold, empty moon, but the idea that it might have microbes living on it makes it a symbol of hope for people looking for life beyond Earth. Its ever-shifting and fascinating plumes make us question where we think life can live and push the limits of what we think is habitable in the universe. Enceladus shows the paradox of a small moon with a lot of potential in these 5 seconds. It is a world of stark, icy beauty with explosive geological activity and the secret promise of life. Its cryovolcanic shows aren't just random eruptions, they're the vibrant signs of a living system. They tell us that creation and change are always at work, even in the farthest reaches of our solar system. As you leave Enceladus, the pictures of its sparkling ice fields and high plumes stay with you. Phobos and Deimos, moons of Mars. Mars has 2 small moons, Phobos and Deimos. They give us a stark, personal look into the troubled past of our nearby red planet. In these 5 seconds on Phobos, you're pulled into a world where every crater and broken ridge shows signs of constant impacts from space and gravity pull. Phobos, which is bigger and less regular than Deimos, dances dangerously close to Mars. It is a steady warning that even the smallest celestial bodies can be violently affected by changes in the tides. Imagine standing on its rough, highly cratered surface, where the ground is damaged from the impact of 1,000,000 times. It looks like the bumpy, disorganized landscape is whispering stories of a long time ago when Phobos was hit by objects and stretched by Mars's strong gravity. While you enjoy this short meeting, Mars looms large in the sky, a huge, reddish object that takes over the view and adds a dark, beautiful layer to the experience. Deimos, on the other hand, has a more subtle, almost ghostly charm. With a smoother, less rocky surface than Phobos's rough, battered land, Deimos seems like a quiet satellite, almost an accident in Mars's busy system. Its surface, which has a few small bumps from hits, gives off a calm, alone vibe, as if time has slowly smoothed over the rough scars that mark its rival. As you look around Deimos for a moment, its softer edges make you want to think more deeply. Light that comes through the thin, unstable exosphere makes soft shadows that move across its surface, making a scene that looks almost tranquil. There is a calm strength here that is very different from Phobos's dramatic and almost wild traits. Deimos looks calm, which suggests that its evolution has been slower and more measured. It is a moon that has stood up to cosmic storms with calm determination, and its gentle face shows the quiet past of the Mars system. Together, Phobos and Deimos embody the dual nature of Mars' influence. One moon reflects the raw, violent forces of near-planetary proximity, while the other exudes a tranquil, almost wistful quietness. In these fleeting 5 seconds, you experience not just 2 separate worlds, but the contrasting narratives of cosmic survival. Phobos's rugged, dynamic surface speaks to a history of relentless impacts and tidal forces, a world forever in flux and on the brink of disintegration. Deimos, on the other hand, offers a softer, more reflective glimpse, a silent witness to the gradual, enduring passage of time, its smoother terrain a record of gentler, cumulative processes that have smoothed away the harsher marks of its early past. We are learning more about these very small things that circle Mars, and it's amazing how important they are to the story of how planets have changed over time. They look very different from each other, and the forces that made them that way are also very different. It's amazing how different things can be, even in the same solar system. We can learn from their small sizes that not all cosmic wonders are huge or full of energy. Sometimes the most fascinating things are right on the edge of chaos and calm. Ceres. Ceres, The biggest object in the asteroid belt turns out to be an interesting world in the middle of hard asteroids and fully formed planets. When you're on Ceres for just 5 seconds, you're taken to a world that is both old and mysterious. Every crater and hill there shows signs of the early solar system. As soon as you step on its rough surface, you get the sense that it is very old. Impact craters cover the ground like a tapestry. Each one is a quiet reminder of the violent crashes and space junk that have shaped Ceres over billions of years. Even though the land looks empty, there are bits of surprising color that shimmer across it. To be able to stand on a surface that shows how the solar system formed. Ceres isn't just a dead rock floating in space. It's a living survivor from a time when planets were still being put together. On Ceres' surface, there are strange bright spots that look like they are covered in icy salt or frozen water when they are lit by weak sunlight. Scientists have been confused by these reflecting spots for a long time. They suggest that cryovolcanic activity might be happening, or that water ice is present not far below the surface. In just 5 seconds, you can see these bright spots that stand out against the dark cratered plains. This suggests that Ceres may still have secrets of active geological processes hidden beneath its old surface. Recent data from the Dawn spacecraft have revolutionized our view of Ceres, revealing not only its intricate surface features, but also tantalizing hints of a subsurface ocean. The bright spots, once a cosmic mystery, may be deposits of salts or cryovolcanic remnants, indicating that liquid water, or brine, could once have flowed across this dwarf planet's interior. These discoveries suggest that Ceres is not just a relic of the asteroid belt, but a dynamic world with a history of internal activity that might have provided the conditions for primitive life. This new layer of insight transforms Ceres from a barren, cratered body into a key piece of the puzzle in understanding planetary evolution in our solar system. The texture of Ceres becomes increasingly detailed. The regolith, the fine, powdery material that blankets the surface, carries with it the scars of countless micro-impacts and the slow, steady grinding of cosmic time. Each step you take is accompanied by the soft crunch of ancient rock and dust, a sensory reminder of the ongoing evolution of this dwarf planet. The interplay of light and shadow on its rugged terrain creates a shifting mosaic, where every crater rim and every smooth basin tells a unique story. Some regions exhibit a more youthful, relatively unscarred appearance, suggesting that localized events, possibly driven by internal heating, may have refreshed parts of the surface in more recent geological times. Ceres has more secrets hidden beneath its complicated surface that show how it works as a world in change. Observations point to the chance of an ocean below the surface, a pool of water ice that may have moved in the past or may still flow in secret spots below the crust. The idea that Ceres' body, which seems to be doing nothing, could hold such an important part of life adds a thrilling layer of mystery. For a few seconds, you are asked to think about the delicate balance between the harsh conditions of space and the possibility for life that might be hidden below the surface. The idea that Ceres might have water that has been kept in the cold void of the asteroid belt makes us think about where and how life could start. It suggests that even the tiniest worlds can be very important in the dance of creation in the universe. The environment on Ceres is defined by extremes, a barren, cratered landscape punctuated by flashes of unexpected brightness that hint at deeper complexity. The temperature variations, though not as dramatic as those on Mercury or Venus, are still significant enough to influence the physical properties of its surface materials. In the absence of a substantial atmosphere, the heat absorbed during brief moments of sunlight is quickly radiated away, causing rapid cooling that contributes to the brittle, icy character of the bright patches. This rapid thermal cycling may be responsible for fracturing the surface, creating fissures and channels that further attest to the ongoing geological activity on this ancient world. The gravitational pull on Ceres is a gentle reminder of its modest size. It is a world where even the faintest force can influence the distribution of surface materials. Without the robust gravity of a larger planet, fine dust and icy particles can be easily lofted into the thin exosphere, creating transient halos of particulate matter that briefly capture the light of the distant sun. This subtle, almost imperceptible movement of material offers a glimpse into the delicate equilibrium that maintains the integrity of Ceres' surface, a balance shaped by both external impacts and internal processes. In these 5 seconds on Ceres, the interplay of these various elements, ancient craters, sparkling bright spots, and the quiet potential for water, paints a picture of a world that is both a relic of the early solar system and a dynamic participant in its ongoing evolution. Ceres is a silent archivist, preserving the chaotic history of cosmic collisions, while also hinting at the processes that might have given rise to more complex, life-sustaining environments elsewhere. It challenges you to look closer, to see beauty in the scars of a battered surface, and to imagine the possibility of life in the unlikeliest of places. Pluto. Pluto, which used to be called the 9th planet but is now called a dwarf planet, has always been mysterious and fascinating to us. In these 5 seconds on Pluto, you'll be thrown into an icy world where history meets stark, alien beauty. It's a frozen scenery that goes against what we think a world should be like. There is a strong feeling of being alone when you step onto Pluto's rough, cold surface. The thin, whisper-like atmosphere barely sticks to the surface, so you can see the landscape clearly, which is made up of deep valleys, wide fields, and tall, jagged mountain ranges. This rock surface, which was shaped by both old strikes and slow, ongoing geological processes, tells a story of history that goes back billions of years in the universe. The crunch of frost underfoot as you traverse a landscape dominated by vast, barren expanses of ice and rock, a world where the remnants of its once grand status as a planet still echo in every crater and ridge. Pluto's terrain is a study in contrasts. On one hand, the smooth, glistening plains formed by the slow, methodical movement of volatile ices. On the other, the dramatic, rugged features like the Sputnik Planitia, a vast heart-shaped basin filled with nitrogen ice that shimmers under the weak sunlight. This basin, along with towering mountain ranges believed to be composed of water ice, suggests that Pluto is far more geologically complex than its diminutive size might imply. The New Horizons journey has given us a fresh look at Pluto and shown us a world with a lot of hidden details. Clear pictures showed Sputnik Planitia, a huge, heart-shaped depression made of nitrogen ice, as well as water ice mountain ranges that are much taller than expected for such a small body. These results show that Pluto, even though it was demoted, is still a geologically active world whose surface is still being shaped by active processes. Pluto is an active example of the mysteries of the outer solar system. Its thin, constantly changing atmosphere and scenery of both old craters and new fields make it a fascinating place to visit. Its history as the 9th planet only adds to its appeal, making us rethink what it means to be a world in the grand scheme of things. The icy wind, which sounds like an eerie whisper, is carrying the secrets of a long-ago world as you stand there. It's so cold that it's hard to imagine, dropping to about minus 230 degrees Celsius, minus 382 degrees Fahrenheit. The cold gets into your bones and makes it hard to tell the difference between solid and mist. Extreme cold, on the other hand, is accompanied by hints of warmth inside. Recent geological activity, as shown by icy cracks and possible cryovolcanic features, suggests that Pluto may not be as dead as it first appeared. In these brief moments, you can almost feel the quiet energy that is still moving below the surface. This is a promise that, even though Pluto's surface is frozen, it still has the possibility for dynamic processes that are shaping its landscape. The history of Pluto is woven into every part of the planet. Its change from a planet to a dwarf planet has not lessened its scientific or cultural importance. In fact, it has made it even more mysterious. Pluto used to be the 9th planet in our solar system, but its demoting has only made it stand out more as a small, icy world on the edge of our cosmic neighborhood. Its remoteness and unique rock combine to make a scene that is both disturbing and beautiful. Every crater and ridge seems to hold a moment in cosmic time that is frozen in place, but still full of the chance for things to change. When light hits Pluto's surface, the weak sun's rays cast long, ethereal shadows over the planet's old, worn-down features. This makes for an almost bizarre scenery that feels like a dream come true. Pluto's thin atmosphere, primarily composed of nitrogen with traces of methane and carbon monoxide, adds an ephemeral quality to the experience. In these 5 seconds, you might catch a glimpse of how this fragile envelope expands as the dwarf planet approaches its closest point to the Sun, only to collapse into near-nothingness as it drifts back into the outer reaches of space. This transient behavior is a reminder of the delicate balance that sustains Pluto's environment. A balance that is both precarious and mesmerizing. The atmosphere's fleeting nature transforms the surface into a dynamic canvas, where seasonal changes occur over decades, sculpting the land in ways that are subtle yet profound. As you absorb the beauty of Pluto, you're also invited to ponder the interplay between memory and mystery that defines this world. Every feature on Pluto's surface is a relic, a testament to the violent collisions and slow, relentless processes that have shaped its evolution. The vast icy plains, punctuated by deep, shadowy craters, are not just static remnants of the past. They are active participants in a story that spans the history of our solar system. The textures and hues you observe, from the soft, almost translucent quality of freshly deposited nitrogen ice to the rugged, pockmarked surface carved by eons of impacts, speak of a world that is both frozen in time and subtly evolving with it. In these 5 seconds, Pluto wants you to look past the fact that it has been demoted and see how important it is as a view into the early solar system. Every part of the place, from the hard crystalline ice to the very thin atmosphere, holds secrets about how planets were formed and how they changed over time. You can't just think of Pluto as a cold, faraway outpost. It's a warning that even the smallest worlds can hold the keys to understanding the big picture of the past of the universe. The Oort cloud. Now imagine going beyond Pluto, past the small planets and the Kuiper belt, and into the farthest parts of our solar system. You will see a huge, spherical cloud of icy pieces that is thought to reach thousands of astronomical units from the Sun. This is the Oort cloud, a place so far away that the Sun only shows up as one bright star among many others. In 5 seconds, you'd hear a silence that was quieter than on Uranus or Neptune. This calmness would cover up the mild storms and small changes we saw closer up. The Oort cloud is the last big space barrier between our known world of planets and the vastness of interstellar space. Picture the scene: a bunch of cometary nuclei, chunks of ice and rock that are sometimes only a few kilometers across, hovering in shaky circles around each other. Each center is a tiny world made of material from the early solar system that hasn't changed in eons. It's quietly floating at the edges, right on the edge where the Sun's gravity almost gives way to that of the galaxy beyond. There are such huge gaps between these things that you could walk millions of kilometers without meeting even the tiniest rock. It doesn't take 5 seconds for any surface to be stood on. Instead, you are surrounded by a cosmic hush where darkness rules, with only a very dim zodiacal or sunlight reflecting off of a rare piece of frozen matter. Within these silent expanses, though, dwell the seeds of comets that occasionally plunge inward toward the Sun, generating magnificent tails seen from Earth. A gravitational nudge, a passing star, a rogue planet, or the galactic tide might set an Oort cloud object on a centuries-long voyage sunward. As the object journeys inward, it warms, shedding icy layers in a glowing coma. By the time it reaches Earth's neighborhood, it may dazzle observers, or, in a less benign scenario, strike the planet as we worry with near-Earth asteroids. Thus, these quiet repositories at the system's edge hold potential chaos. Each is a cosmic arrow waiting to be loosed under the right gravitational impetus. From your 5-second viewing point, you might be able to tell that comets start out as plain lumps that fade away in the darkness. It's too cold for life to survive here. There's no warmth, and the temperature hasn't changed in a long time. When you look straight at the sun at that moment, it's nothing more than a pinprick. Its brightness is just a memory of how strong it is when it burns Mercury or lights up Saturn's rings. From the hot side of Mercury to the almost empty space of matter and energy in the Oort cloud, the same star connects these two extremes, pulling them together into a single gravity field. They are so far away that even at light speed, signs from Earth would take hours to get to you. No longer is the sun's gravitational pull absolute. Forces from outside our galaxy or from stars going by can change paths in ways that never happen close to Earth. You can also see the Oort cloud's role in the history of the universe in these 5 seconds. Some ideas say that comets brought water and organic chemicals to Earth, which sped up the processes that led to life. In this way, the Oort cloud is not just the edge of the universe. It is a place where many options can be found. It is the last watchtower of the sun's power, standing between our star's direct impact and the endless star-filled space between the stars. It might not seem to change, but over thousands of years, cosmic forces could kill off its inhabitants or add new ones by capturing other objects. The items in the Oort cloud could bring building blocks to new worlds and help them form, or they could destroy worlds that are already there. When you come back from the edge after these 5 seconds, you'll have a better sense of how big things are. The Oort cloud shows that the solar system goes much further than Neptune or Pluto's orbits. It forms a cosmic nest around our star that blends invisibly with the matter in the galaxy as a whole. There is a blurred line between our home system and the cosmic beyond in these zones, which are so far away it's hard to imagine. Every brief image we get, like Mercury's heat, Saturn's rings, or the Oort cloud's silent guards, makes our view of Earth more profound. Haumea. Haumea is one of the strangest dwarf planets in our solar system. Its long shape, fast spin, and surface covered in crystallized ice make it stand out. During these 5 seconds on Haumea, you'll see something that doesn't look like a normal round, calm sphere. Instead, Haumea's long shape and spinning spin make a strange, moving world that suggests a violent past and an even stranger present. As you take in this brief glimpse, each moment is a study in difference. The frozen, sparkling surface tells stories of past collisions and ongoing rotational forces, and the dwarf planet's shape questions what we think we know about planetary bodies. Imagine a world that looks like it was shaped and stretched by powerful forces, with a shape more like a cosmic egg than a planet. Haumea spins so fast that it makes a big bulge around its equator. This gives it a very long shape. Its shape is determined by its constant spinning, which also changes its geology. Centrifugal forces move the materials on the surface around, making a complex mosaic of smooth fields and rough, broken landscapes. The surface is made up of a beautiful pattern of crystalline water ice that reflects sunlight so brightly that it seems to light up the dark edges of the Kuiper belt. Every flicker of light and small change in color on Haumea's icy surface gives us a fascinating glimpse into the processes that have formed its evolution over billions of years. Haumea's peculiar form is believed to be the result of a colossal collision in the Kuiper belt, a cataclysmic event that shattered a once larger body and set Haumea spinning at incredible speeds. This rapid rotation has stretched it into an elongated shape, while also influencing the distribution of surface material, which now glistens with pristine crystalline ice. Adding to the intrigue, Haumea is accompanied by a pair of small moons that orbit it in a delicate gravitational dance, further evidencing the violent forces that sculpted this dwarf planet. Together, these features paint a picture of a world forever transformed by cosmic impacts, where the echoes of an ancient collision continue to reverberate across its shimmering surface. For even a short 5-second time, when you stand on Haumea, you can almost feel the effects of its fast spin. The strong centrifugal force pulls the surface outward, making cracks and grooves that run the length of the dwarf planet. They look like the scars of a cosmic fight that defied the rules of physics. These cracks and grooves are not just passive features, they are active clues to Haumea's internal structure and past, showing that it has been through huge impacts and major internal reforms. The very clear and pure ice on the surface tells scientists about water that has been kept almost perfectly. This gives scientists a unique look into the early materials that made up the solar system. Adding to Haumea's unique look is the way that light and shade play off of its surface. The ice field's high reflectivity makes for a stunning visual effect, a natural, sparkling show that stands out against the dark, faraway background of space. In these brief moments, you see how the sun dances across Haumea, making designs that change all the time and show off the delicate curves of its strange shape. The bright ice not only draws attention to the planet's bumpy shape, but it also suggests that Haumea may have had relatively recent resurfacing events, where the exposure of new crystalline ice has turned back the clock on its old damaged surface. Also, Haumea is not the only object in its solar system neighborhood. It has two small, interesting moons that rotate close by, making this already interesting dwarf planet even more complicated. These satellites are held in place by Haumea's gravity and move in a careful dance around the Sun that shows how dynamic this system is. Their existence supports the idea that even on the farthest, coldest edges of the solar system, interactions between stellar bodies can create complicated gravity patterns and maybe even more rocks moving. Here on Haumea, the tiny planet, you have 5 seconds to rethink what a world is. This object's long, fast-spinning shape and surface that shines like new snow under a cosmic spotlight reveal the turbulent past and current changes in the outer solar system. A bright example of how collisions and fast rotation can change things, Haumea is a lesson that even the smallest and most seemingly unimportant bodies can hold amazing secrets. Imagine how the forces of nature can change the world into something incredibly strange and incredibly beautiful, going against what most people think about shape, stability, and natural calm. Makemake. Makemake is a strange dwarf planet far away in the Kuiper Belt that gives us a look into a world of frozen solitude and a soft, enticing charm. In these 5 seconds on Makemake, you're invited to see a place that, despite being far from the sun, shines with a quiet, magical beauty. This is a landscape that has been shaped by time and the relentless forces of the outer solar system. Taking a step onto its cold surface makes you feel very alone at first. It's very cold outside, and the air, if you can even call it that, is a thin layer of flammable chemicals that suggests an atmosphere that is so thin that it almost disappears when a breeze blows through. Even though Makemake is almost empty, its surface is stunningly varied in color and texture, a quiet reminder of the frozen processes that have shaped its shape over billions of years. Standing on a terrain where every inch is covered by a layer of ancient ice, its crystalline structure reflecting the distant, feeble sunlight in a spectrum of muted blues and greys. The surface is rugged and scarred by impact craters, each one a silent witness to the chaotic history of collisions in the early solar system. Amid these scars, however, there are regions where the ice appears freshly exposed, a delicate, almost transient brightness that suggests recent resurfacing events. These features hint at a dynamic history, where even a world as remote as Makemake is subject to the slow, inexorable march of geological change. The interplay of light and shadow on the icy plains creates a mesmerizing, almost ethereal landscape that invites quiet contemplation. A serene yet stark reminder of the fragile beauty hidden in the far reaches of our cosmic neighborhood. Under the frozen surface, there is a mysterious allure. Makemake might have a very thin, temporary atmosphere made up of nitrogen or methane that comes and goes with the seasons. This whisper in the atmosphere is so weak that it tests our ability to pick it up. It comes from a world where it's hard to tell the difference between a barren ice ball and a possibly more busy, if subtle, planetary body. In these 5 seconds, you can feel that every little thing, the ice's slight shimmer in different lighting, the color changes that happen across its surface, carries the weight of ancient cosmic events and the promise of secrets that have yet to be solved. To me, Makemake seems like a quiet keeper of secrets, Its frozen embrace holds the building blocks of planetary development and maybe even the conditions that could lead to the emergence of the basic forms of life. The surface of Makemake, which is made up of rough, highly cratered ice, shows signs of its long, turbulent past. Recent studies show that Makemake might sometimes create a thin, temporary atmosphere mostly made up of nitrogen or methane. This atmosphere seems to change with the seasons. This short-lived layer of atmosphere suggests that the dwarf planet is still being affected by dynamic processes that affect its surface and temperature balance, even though it is very far away. These soft whispers in the atmosphere add to the wonder of Makemake. They show that even the coldest, most isolated worlds in the Kuiper Belt can go through small changes that are similar to how planets evolve all over the universe. As you stand on Makemake, the vastness of the Kuiper Belt stretches out around you, a cosmic expanse where time seems to slow and the usual rush of the inner solar system is replaced by a deep, introspective stillness. The isolation of this dwarf planet is palpable. It exists on the fringes of our known celestial neighborhood, a solitary outpost in a sea of darkness. Yet, this seclusion only adds to its allure. In the stark light of distant stars, every texture and every subtle line in Makemake's surface becomes a story, a record of millennia of cosmic evolution written in ice. The very act of witnessing this frozen relic in a brief 5-second encounter is an invitation to imagine the myriad forces that have shaped not only Makemake, but the entire tapestry of our solar system. Makemake questions your idea of what it means to be a planet in these brief moments. There aren't any big storms or blazing heat that define it. Instead, there's a quiet endurance that speaks to the slow, careful processes that run the outer solar system. In the cool quiet of this faraway dwarf planet, every bit of light and every tiny crack in the ice sounds like it comes from a long time ago. Makemake is a great example of the huge variety of worlds that exist beyond the familiar warmth of our inner planets. It's a world where time is marked not by big explosions, but by the slow, almost unnoticeable dance of light and dark. Eris. Eris, the biggest of the dwarf planets, stands as a mysterious icy mystery at the edge of our solar system. It is a place of deep isolation and reflective beauty that makes us think about what it means to see a world as beautiful. For 5 seconds on Eris, you are thrown into a world where every tiny bit of light and color on the frozen surface tells you about the secrets that lie in the Kuiper Belt's dark depths. You can feel how stark and pure Eris is as soon as you step on its surface, even if it's only for a moment. The scenery is a stunning show of bright ice and dark old rock. It's a painting made by billions of years of cosmic history and the constant forces of space and time. Standing on Eris, where the surface is so cold that even the faintest warmth from distant stars seems like a gentle caress. The temperature here plummets to extremes that make Earth's winter feel like a mild, fleeting chill. In the absence of a substantial atmosphere, every detail is laid bare. A vast, unyielding terrain marked by deep fissures, jagged craters, and smooth expanses of reflective ice. The light of the distant sun, though feeble, plays across Eris's surface with a mesmerizing clarity, casting sharp, contrasting shadows that reveal the intricate textures of a world both ancient and strangely pristine. Every fragment of ice, every rough-hewn depression, tells a story of collisions and cosmic evolution, a narrative of creation and destruction that has shaped Eris over eons. Eris stands alone in the farthest reaches of our solar system. Its smooth, mirror-like surface reflects the faint light of stars far away. Because Eris is so far away from the inner planets and their changing influences, its environment stays surprisingly stable, even though its past has been very unstable. Its highly reflective surface, which is mostly made up of frozen methane and other volatile chemicals, creates an effect that is almost dreamlike and pure, capturing the essence of cosmic endurance. Eris's icy beauty and the slow, steady changes that have kept it that way for billions of years can both be seen in the way light and shadow interact with each other. This planet's steadiness, along with its dramatic past, questions our usual ideas about how planets change over time and shows how complicated even the farthest away celestial bodies are. Eris is defined by its isolation, a solitary beacon in the remote, inky expanse of the outer solar system. This seclusion is palpable. As you gaze around, the overwhelming sense of distance from the familiar comforts of the inner planets creates an almost otherworldly stillness. Here, in the farthest reaches of our cosmic neighborhood, Eris stands as a monument to the unknown, a world that exists on the margins of light and warmth. Its reflective surface, composed largely of frozen methane and possibly other volatile compounds, gives it an almost mirror-like quality that not only captures the pale glow of the sun, but also hints at the mysteries hidden beneath its frost. Every glint and sparkle on Eris's face is like a fleeting secret, an invitation to wonder about the processes that have preserved its icy facade for billions of years. In these 5 seconds, you are also struck by how Eris's harsh surroundings and the delicate balance that keeps it alive work together. Eris's surface is constantly hit by cosmic rays and micrometeorites because it doesn't have an atmosphere to protect it from space's harshness. This is a quiet warning of the constant eroding forces at work. But the way the ice and rock live together in a careful balance gives this exposure a clarity and purity that is all its own. Because there is no atmospheric distortion, you can see every little detail, like the deeply cut lines in the ice, the delicate layers of sedimentary deposits, and the ghostly marks left by impacts that happened a long time ago and damaged the surface. The scenery is both harsh and beautiful. It's like a frozen scene where everything is connected to the secrets of the early solar system. Eris challenges our conventional understanding of what it means to be a planet. Its massive size among the dwarf planets, coupled with its extreme isolation, makes it an emblem of the outer solar system, a silent guardian of the cosmic frontier. The fact that Eris is located so far from the Sun means that its environmental conditions are remarkably stable, yet its surface still bears the hallmarks of a turbulent past. In a few brief seconds, you witness a world where the echoes of ancient, violent events have been preserved in the shimmering ice, where the passage of time is measured not by rapid changes, but by the slow, inexorable processes of cosmic evolution. Every moment on Eris makes you think about the delicate balance between being weak and being strong. Its stark, reflective surface not only shows how hard the outer solar system really is, but it also serves as a lesson that nature can create scenes of great beauty and subtle complexity even in the most remote and harsh places. There is a lot of quiet on this faraway world, where every breath of cosmic wind carries the weight of thousands of years. This world seems to hold the secrets of the universe in its cold, unbending grip. Saturn's hidden gems: Mimas, Tethys, Dione, Rhea, and Iapetus. A family of moons lies beyond Saturn's beautiful rings and the famous site of Enceladus. Their stories are just as interesting. Mimas is the first moon. It is often called the Death Star moon because it looks a lot like the famous space station from a sci-fi story. You'd see a harsh, frozen environment full of craters in 5 seconds on Mimas. The biggest one, Herschel, takes up most of the view. Think about Mimas's hard, icy surface under a pale, faraway sun. Each impact scar shows how the tiny world has been changed by violent crashes over billions of years. The dramatic, almost perfect circle crater stands out against the moon's smooth, icy plains, making a puzzle that makes people wonder about science and feel amazed. As you stand on Mimas, you can almost hear the sounds of impacts from long ago echoing through the cold, still space. This is a warning that even the smallest bodies in the solar system have scars from their troubled past. Next, envision Tethys, a moon that offers a sweeping panorama of both ancient craters and sprawling canyons. In 5 seconds on Tethys, the surface would present a mesmerizing interplay of light and shadow, where the immense Ithaca Chasma, a canyon system stretching for hundreds of kilometers, reveals layers of the moon's geologic past. The surface here is a mosaic of rugged terrain and smoother plains, hinting at episodes of resurfacing that have erased some of the older scars. Tethys's deep, dark craters contrast with the brighter ice, giving you a sense of timeless isolation and unyielding beauty. Imagine the crisp clarity of the ice, every fissure and crevice a silent record of cosmic time, all illuminated by the subdued glow of distant sunlight. Then there is Dione, a moon that elegantly walks the line between calm and chaos. During these brief times on Dione, you would see a world where areas with a lot of craters give way to areas with strangely smooth fields, as if nature had chosen which parts of its rough past to smooth out. The interaction between bright, reflective ice and darker, older scars makes for an environment that is always changing. It's like time has drawn its story on a canvas with small, intricate strokes. If you stand on Dione, you might feel the soft pull of its gravity field. This is a gentle reminder of how slowly it changes over time. This peaceful difference makes you want to think about the long, silent story of a moon that has stood strong through many cosmic events. Rhea offers another perspective, a world of expansive, gently undulating plains and subtle geological features that hint at a more complex internal structure. In 5 seconds on Rhea, you would be captivated by the soft, muted textures of its surface, where the interplay of light creates a patchwork of shadows that shift slowly across an ancient ice-lined terrain. Rhea's surface is less dramatic in terms of active volcanism or colossal impacts, but its quiet, unassuming beauty is no less profound. The surface tells a story of gradual, persistent change, a slow, almost imperceptible evolution that speaks to the enduring, persistent forces of nature. It's as if Rhea is a peaceful archive of a time when the early solar system was still in the throes of formation. Its every contour a gentle reminder of cosmic patience and the relentless march of time. Finally, Iapetus provides a dramatic, almost cinematic farewell to Saturn's family of moons. Known for its striking two-tone coloration, where one hemisphere is as dark as night and the other gleams with a bright icy light, Iapetus is a moon that immediately captivates with its visual dichotomy. In these 5 seconds on Iapetus, the stark contrast between the dark, mysterious terrain and the sunlit, reflective surface creates a surreal, almost theatrical scene. The boundary between the two hemispheres, a sharp line of demarcation, seems to slice the moon into 2 distinct worlds, a puzzle of origin that has intrigued scientists for decades. As you stand on Iapetus, you might feel an almost eerie duality, as if you're witnessing 2 different histories unfold simultaneously. A dark primordial past juxtaposed with a later, more refined evolution. The soft echoing silence of Iapetus, punctuated by the shifting play of light on its contrasting surfaces, is both haunting and profoundly beautiful, a reminder that even in the cold expanse of space, art and mystery are intertwined. Uranus's mystical satellites, Miranda, Ariel, Umbriel, Titania, and Oberon. Miranda is one of Uranus's moons, and its surface is made up of a patchwork quilt of strange, almost surreal landscapes. During these 5 seconds on Miranda, you'd be surrounded by a crazy mix of steep rocks, deep valleys, and huge broken terraces. The landscape, shaped by ancient geological forces and potentially disastrous impacts, makes for a scene that is both amazing and very confusing. It looks like Miranda's surface has been torn apart and put back together in a cosmic collage because of the complicated patterns of hills and valleys. The big changes in height and texture make you feel both beautiful and alone. They are a warning that nature's forces can change things dramatically, even in Uranus's frozen world. Another beautiful moon of Uranus is Ariel, which has a different kind of cold beauty. In just 5 seconds on Ariel, you'll be in a smoother, more mirrored environment, where clear, bright ice takes up most of the view. Deep valleys and ravines on Ariel's surface suggest that the planet's geology has been very active in the past. It's possible that cryovolcanism or tectonic uplift have changed the planet's shape in the past. Its soft, light colors, from icy blue to soft gray, give it a peaceful, almost dreamy feel. They make you want to get lost in a world where time seems to stand still. As you move through this short encounter, the way light and shade play off of Ariel's mostly clean surface creates an almost ethereal atmosphere. It's like a visual melody that speaks to the delicate balance between calm and change. Moving on to Umbriel, you enter a realm of subdued mystery, a moon whose dark, moody surface is shrouded in an almost perpetual twilight. In these 5 seconds on Umbriel, the landscape is dominated by a deep charcoal hue, punctuated by isolated bright spots that suggest the presence of exposed ice or even ancient frozen deposits of organic material. Umbriel's surface is less active than that of Miranda or Ariel, yet its brooding, somber beauty is no less compelling. The muted light, combined with the quiet, almost melancholic terrain, creates an atmosphere of introspection and ancient wisdom, a silent narrative of a world that has seen the passage of countless epochs without the dynamic upheavals of its more vibrant siblings. Titania, the largest of Uranus's moons, offers a different kind of majesty, a world where expansive plains and deep craters coexist in a harmonious yet rugged landscape. In these 5 seconds on Titania, you'd be struck by the smooth, gently undulating surfaces that stretch into the distance, intermingled with sharply defined impact basins that testify to its violent past. The light on Titania is soft and diffuse, casting long shadows that accentuate the moon's topographical diversity. Its relatively smooth terrain suggests that, at times, Titania has experienced episodes of resurfacing, perhaps driven by internal heating or gradual tectonic processes that have erased some of its older scars. This interplay between ancient preserved features and more recent geological activity creates a compelling narrative of renewal and decay, a delicate dance that has unfolded over billions of years. Oberon, Uranus's farthest major moon, is a reminder of how the ice giant formed and how it has changed over time. In these 5 seconds on Oberon, you see a world that is both rough and timeless. The surface is marked with deep craters, scars from long ago, and a mix of icy fields that make you think of the raw, early processes of planets forming. Oberon's surface has a beautiful, almost sad look to it. The way the dust and ice interact makes for a soft, smooth landscape that looks like it has been through many cosmic crashes. As you stand on Oberon, the cold, faraway light of the sun gives the surface a soft glow, turning its rough edges into an otherworldly patchwork of light and dark. Oberon's quiet, modest beauty is a strong reminder that even the farthest satellites can hold the history of the solar system. This history is a silent record of creation and destruction that moves at a steady, patient pace. Neptune's distant daughters, Proteus, Nereid, and Larissa. Looking at Neptune, we see that besides Triton's dramatic appeal, the blue giant has a number of lesser-known moons orbiting it, each with its own personality. One of these moons is Proteus, a small, bumpy body that has a rough, worn-in beauty despite its small size. In these 5 seconds on Proteus, you would be on a surface that has been hit many times and has a texture that shows a past of constant crashes and slow wear and tear. The rough form and surface of Proteus are a stark reminder that even the tiniest moons can be affected by the unstable forces that govern the outer solar system. Its dark cratered surface, lit by the faint glow of Neptune's reflected light, shows a world that has survived the chaos of space violence. This shows that even the smallest celestial bodies can be strong over time. Nereid is another interesting moon of Neptune. Its very strange path and changing light make it one of the most mysterious objects in Neptune's system. During these short stays on Nereid, you'd be struck by how random it is. A world that goes in and out of Neptune's grasp, with the planet's distance from Neptune changing greatly over time. The surface of Nereid is thought to be a mix of rock and ice, and the way it reflects light suggests that it has been hit in the past and resurfaced several times. Imagine how exciting it would be to see a satellite whose path across the Neptunian sky is neither smooth nor circular, but rather a heavenly traveler whose path is both hypnotic and mysterious. The way light moves across its rough, uneven surface and the different viewing angles make for a dynamic visual fabric that captures the wild, uncertain spirit of this faraway world. Another interesting moon of Neptune is Larissa. It is a small satellite that moves closer to the planet. In these 5 seconds on Larissa, you'd see a world that isn't as exciting as Triton or Nereid, but still has its own quiet charm. Its surface is smoother and more uniform, which suggests a more stable geological history. However, small surface features and hints of past hits give the impression that the rock has been there forever. Larissa is very close to Neptune, so it gets light from the planet that bounces off of it. This gives it a soft glow that makes it stand out from the darker, less stable moons farther away. Larissa is an interesting contrast because of its soft glow and small size. It is an almost unassuming satellite that tells a quiet, long-lasting story of the forces that have changed Neptune's realm. Pluto's compelling companion, Charon. It would not be fair to study Pluto's world without taking a close look at Charon, its biggest moon. During these 5 seconds on Charon, you enter a world that is closely connected to Pluto. It is a binary system where the two bodies are dancing in space with their gravity pulls on each other. Even though Charon's surface is cold and looks a lot like Pluto's, it shows us something different about the past of the Kuiper Belt. Picture a landscape with deep chasms, wide fields, and tall rocks that tell a story of violent strikes and subsequent geological renewal. Charon is a co-star in this story of the stars because it is bigger than Pluto. Both bodies came from the same place and were shaped by past crashes and tidal forces. If you stood on Charon, you could feel how deeply it is linked to Pluto. In fact, the link between them is so strong that they are often thought of as a double dwarf planet system. Charon's surface has large scarps and smooth, shiny areas that show it may have been a cryovolcano in the past, just like its bigger neighbor. Charon's rough terrain and the way light and shade interact with each other create an atmosphere of deep reflection. It is a place where the sounds of ancient impacts and the slow, steady passage of time come together to make a landscape that is both harsh and strangely beautiful. Pluto and Charon are locked in synchronous spin by their gravitational pulls. This means that while you are on Charon for 5 seconds, you are also a part of a bigger cosmic choreography, a silent, long-lasting dance that has been going on for billions of years. It's interesting to think about how deeply celestial bodies can change together because of this close connection. Other minor bodies and Kuiper Belt objects. Beyond these satellites, the outer reaches of our solar system are home to many smaller things that, while not as well known, hold secrets about how the universe formed and how it has changed over time. Take Sedna as an example. It is a mysterious object that moves far beyond Pluto in the inner Oort cloud. In these 5 seconds on Sedna, you would see a world where time seems to go on forever. It is a cold, dark, lonely body that holds the remains of the early solar system. The path that Sedna takes is very long, and it goes through the farthest, most remote parts of our solar system. There, the sun's dim, cold light makes long, frightening shadows on the ancient surface. Its icy surface, which is marked by small impact marks and long-forgotten cosmic scars, gives us a glimpse into a world of complete isolation. It serves as a warning that the edges of our solar system are both mysterious and empty. Another interesting object can be found in the Kuiper Belt, which is full of icy bodies and pieces of planets that have already formed. Even though they are small, these minor bodies make up a picture of how the solar system came to be. Each one is like a tiny time capsule that holds the chemical and physical conditions of a long time ago. In a 5-second interaction, you could imagine falling on one of these icy pieces and seeing how the ice, rock, and organic compounds on its surface interact with each other. These Kuiper Belt objects have a wide range of colors and textures. Some shine like fresh ice, while others are darker from being in space and being exposed to cosmic radiation. They are what the bigger planets are made of, and their quiet, modest presence shows us the true story of how we got here in the universe. As you learn more about these other small bodies, like Sedna or the groups of icy leftovers in the Kuiper Belt, you get a better sense of how diverse our solar system is. These things are very important to understanding how our universe was formed, but they are often forgotten in favor of their bigger, more interesting cousins. They tell us that every part of the world, no matter how small, has a story of how it was made, how it has changed over time, and how it will change again. From the scorching extremes of Mercury to the icy isolation of distant dwarf planets like Eris, our whirlwind tour has revealed the breathtaking, bizarre, and sometimes terrifying diversity of worlds that share our cosmic neighborhood. These 5-second snapshots remind us that while our home Earth is a haven of familiarity, the universe teems with untamed frontiers waiting to be explored. So keep your eyes on the stars and your curiosity burning bright. There's always more to discover just beyond the next celestial horizon. If you enjoyed this journey through the solar system, don't forget to like, subscribe, and hit the bell so you never miss an adventure into the cosmos.